Hi everybody. Today I want to start about statistic. My first lecture is about biostatistical methods. As you know, the biostatistic is the study of the biology in the mathematical and in the statistical form. Today I want to start with the descriptive statistics. For this reason, we will study hypothesis test or statistical test, which are related to type of data. Usually in our experiment or research, we have a data, the nature of the problem, and what type of the problem we can have in the research, and the statistical model which shows in which method or model we can use for define the solution or result. For this reason, I start with descriptive statistics. As I mentioned, in the statistic, we usually need data and the data set. And for this one, we need to make a data table. Okay, the data set or data table contain information about, okay, number of the individuals. For example, in the individual, we can have a records or data from our hospital or our drug data, and all of this can be important for us. For example, individual, for example, in the clinic, we can say individual data, for example, the records about the patients and the records about the peoples and the medicines. Or for example, generally in the animals or everything we can get. Then we can say individual are the object described set of data which they make people or animal or things. Okay? Then for each individual, usually we give the values for one or more values. Okay. Then we can say our data set has a two parts, individual and variable. For example, as you see, the variable is shows the characteristic of the individual. It is related to the individual. For example, if we have a patients in the hospital, they are individuals, and the variable is their age, their gender, their blood pressure, their problems, their height, their salary, for everything. Then we can say variable is related to the individual. It shows us the characteristic or information about the individual. For example, if you see here, it's very important. As you see here, we start to conform the people as an individual with a number. Okay? For example, we can get a number, or every number has a name. For example, we can say first patient is the Peter. Second patient is like X, Y, and other. Okay? As you see here, we have a variable for each individual. For example, Peter can be male, first variable. And the second variable is, you see, it is age is 25. For example, blood pressure, it is 140 to 80. Height is 185. Weight 100, for example, 85 kilogram, 185 centimeter. As you see here, we can have a different variable in these columns, which shows information about our individuals, and it is very important. Here is the one data table or data set. As you see here, data table or data set. As you see here in the individual, we have a groups. As you see, we have 18 individual controls, 5 controls, 4 estrogen, 4 progesterone, and 5 again mix of them. As you see here, and these are the variable, and this column is individual. Then we can say individual shows us which group or which set of data usually we study about it, and the variable is the related characteristic about individual. Or for example, the data table about student. If you see here, we have a student name and the number. Here we can say it is individual. And as you see here, gender, age, height, mass, equal height, equal mass, and it and I, or everything, we can say they are variable for the patient or student, sorry. And it shows the data set. As you see here in the data set, we can have information about the student, and each student has a variable information which shows us about the characteristics. Now, the second important question when we start this lecture, I explain about it after data is the problem. Okay, problems can be planned in the research. Okay, then for the making problem or for to solve the problem, usually we need a data table or data set. And data table has an individual and variable. Okay, as you see, we need the first for the problem, we need the one plan. Okay, then after when we got a plan, okay, we can find answer for our problem or the problem which is created. Okay, it's very important. For example, if you see the topic here, the boys and the girls eat tomato soup often. Is it in relationship with their body height? Then if you see here, there is a relation between the variable and it can be shows us the problem. What will be variable? We can say variable can be gender, body height, and it. What will be in the row? It can be the name of the student or the number of students, which be individual. Then we can write here, in this slide, we can write students. Here we can write gender, or we can write height, or it, and we can say student, we can have a number or the name, and we can say like this table, we can make a table for this case. As you see here, what I explained in the last page, we can show in the gender and tomato and the body height and also the student in this column. And every row about this we can start with the student name or student number, and we can see the relation between the individual and the variable. Because if you see his individual about student and we say the variable, it shows what is the relation between these two, and it can help for the solve the problem or continue the result of the research. What is the difference between the variable? As you see here, gender and height, they are concerning possible value or question. It's a very good question. As you see here, I explained before, for example, gender, height are variable. It shows about individual. Every students are individual and they have a gender or height. Their characteristic, it is their characteristic about the student. Okay, for example, for the gender, we have two possibilities just, and in this case, just we can show we have a male or female. But for the height, we don't have just two. Usually we have an indefinite result or more different result. In this case, we can say here we have a two possibility, but we have a theoretical infinite possibility because of the every person can have their own height. Okay, then we can say the gender, it is a categorical or discrete because it shows two categories. And the one category is the male. The second category is the female. But the variable of the height, it is continuous because it can start from maybe the small baby from maybe 50 or less centimeter or more than 2 meter or 200, for example, around 250 centimeter. And each of them can be, all of them can be different in the small data like a millimeter also. For example, 185.3 height and 185.1 centimeter, which is a different variable in the height. Type of the variable, as I mentioned for you, we have two types of the variable. Okay, which the first one is the categorical or discrete, which shows we can have the spatial and finite set of the possible value. For example, in the gender, we have a two finite set of the data, male or female. Blood group, we can have A, B, AB, and O. Okay, or number of the children for family can be fixed. But in the continuous, the data is infinite, and we can have the just minimum and the maximum, which I showed you. For example, concentration can be start from the 0 until the big value. For example, this is C1, C, or Cx. It is an infinite set of the possibility of temperature can start from the -2 and the positive infinite. But okay, maybe some of them we can reach, some of them we cannot reach. For example, 1 Kelvin, 0 Kelvin, 1 degree centigrade, or -300 centigrade. Usually, it is very extra information about using Excel. We can sometimes use some software. For example, we can use the Excel. In the statistic, Excel can be useful, but not very professional. Then we can use other software like SPSS or other data or R program. Then Excel is not very good for this situation, but Excel is very good for collecting data. It's very important if for collection of data and forming of database or data table. It is very good, and we can make a data table. And or we can mention writing the variable, make a column, or we can make a good table about variable and individual. Then we can export to the other software for the make of this problem, to solve of the problem. Okay, and in this case we have some problems I mentioned before. Sometimes it's not better we use a question mark or other characters, or missing value lives in the cell, empty cells, and also finding of the processing of the statistic in the Excel can be problem. As I mentioned, for the statistic calculation we can use SPSS, our program, or there are many new programs which can be free or it has a cost. As you see here, we use Excel. As you see here, we have a individual data, and we have a variable start from here. As you see here, about weight, sex, age, height, and eye, color, sport, and everything we can have. And it can be continuous or in the other form. And as you see here, it is we can make in the Excel very good table. And as I said for you last we have a categorical variable which is it is definite. For example, we can say for the gender we can have a categorical variable, because we can, if you see here in the x-axis, we can have a sex, we can have a male or female. As you see here, we have two category. Because of this category, it is we can say it is a categorical variable. Just we have a two column. But as you see here table, we have a 12 female, male, and 8 female from the total 20. If you see here, if the 20%, we have a 12 male and 8 female. If you see here, it is a 12 for the male and 8 for the female. It's very important. Usually we show in the x-axis in the categorical variable, and in the y-axis we can count the number, or we can relative frequency or the percentage or everything we can show in this table. And in this chart we can make a different type of the chart. We can say bar chart. We can use a bar chart. For example, here we can see bar chart about frequency and relative frequency. Or we can use other table, like for example, if you see I make one of them. Okay, as you see here, I make a table for the male is here and the female is here, and if you choose 12 is here and 8 is here. As you see, we can show paint, or we can make a line between them. And as you see, we can show in this form also in the point or with the line also. As you see here, we can show the several different example for categorical variable. If you see, we can show months, or the number of the children. If you see in the different column, different year, different age, and we have a categorical variable for the male and the female, as you see in this table. It is a female or girl, and it is a boy. And I have one question. It is very important and easy question about homework. You can find the categorical variable in your data set and complete this with this number, or for example, type of the food we can make by the tomato or something which is in this example. Now we go to the distribution of the continuous variable. As I mentioned before, categorical variable, it is finite, but in the continuous variable, it is indefinite, and usually the set of data, it is not definite, it can be has a minimum or maximum, but sometimes we study about between two minimum and maximum, which is we defined. The distribution of the continuous variable usually speak about how often the variable fall into the interval, and we always set this interval, and we show in the graphical form in the histogram. As you see here in this age set, it is a age, which is it is a continuous variable because it can be start from the 0 until 100 year or more. But in our example, we mentioned we use from the 0 to the maybe 70 years, and we show in the histogram the number of this type of the patient or in the clinic, and we showed, for example, 3 patients with the age of the 5. In the 15 we have a 5, in the 25 we have a 8, or in the 30 we have a 1. As you see here, we can have this data of, if we want to make a graph about this, we can put the numbers closer each other, and we can make this also line. As you see here, the individual, it is a continuous variable. It shows the relation is not definite, and it is between the one minimum and the one maximum. And it shows the individual in the y-axis. As you see here, in the continuous variable, if you see, we have values, we have a categories, and we have a frequency. As in the shows, we shows in the age as the continuous variable. It starts between the minimum 0 and the maximum is this, for example, 60. And we have a individual set of data here, and we have a category, it shows here, and each category is related to continuous in the x-axis. And in each category, it is a continuous variable. We can find the number of the individual, how many individual we can have in the same frequency, and it's very important. And now we continue the problem. For example, we study a problem about one example about the height. I give you 2 examples which we studied before as a summary. I explain about the discrete variable, which shows a definite variable in value. And for example, like gender, we have a just male and female. And I spoke about the continuous, which is we can have the indefinite variable, but it has a minimum or maximum. And this is the data we can calculate about these 2 interval. For the discrete, in the distribution will be in the categorical variable. I show you is very important. and it shows the value it takes and how often it takes these value. But in the continuous we have a continuous variable, and again it shows this situation, but it has the, in the continuous variable we can have the minimum and the maximum, which is very important for us. And in the overall pattern of the distribution, we can also start, it is a new system, how our data can be distributed in the systemic. And as you see here, it can be different shape of the distribution. If there is a systemic or bell shape, we can say systemic or bell shape, or it can be symmetric, it can be skewed to right or to left. It can be symmetric or non-symmetric. It can be non-symmetric and bimodal, or can be symmetric or bimodal, it's the same shape. It can be symmetric and unimodal, and also it can be uniform. As you see here, the shape can be in two forms. As I mentioned, it can be symmetric or non-symmetric. Non-symmetric can be skewed, and it shows the distribution is not symmetric shape. And data can be in the center or spread or shape, different shapes we can have. And about skewed, we can have the right or left skewed. For example, you see here almost one symmetrical diagram, and the one right, and again other one is also right. As you see here, if we want to draw the shape, it is almost like a this. And here if you see like a this form, and information is different shape, because in this case you can see the distribution can be in two forms. It can be skewed and or in the symmetric. And outliers explain about what is the observation about the outside of the overall pattern of the distribution. Always we can try to explain them. It shows the real data and type and form of the data. It can help us to solve of the problems. And describing continuous distribution with number. Usually for the continuous distribution, we usually use a number, okay? Because in this case, in the histogram, it can be all more useful, and we can use this data, okay? For example, measure of the center, we can usually use the mean value or mode value or median, because in this case we can see good information about our data. And or for the variability, usually we can use the range. It can show between which or quartiles or variance, standard deviation, and also the variability. Usually we can use for the measure of the variability or measure of the center, we can use the mean and the mode and the median, and it can show our system is skewed or symmetric. And we can use for individual, we can use the rank and the z score. Then it's very easily we can set up the data with a nice information which can give us the set of information which is more better than histogram, which is the graphical method. Okay, now I want to start measure of the center of the distribution. For example, I have a set of data. For example, I have a 1, 2, 4, 1. If you see here, for the mean, we have to find the average. Average is the sum of them divided for the number of the individual. It will be 1 plus 2 plus 4 plus 1 divided for the number of n is the 4 is the 2. Okay? More the number we use it more frequently, it is a 1 here. Okay? It is very easy. And the median, we have to sort the data with the small to high. If you see, it is in this data. Okay? We can use this data for the median as a sort 1, 1, 2, 4. As you see here, when we have a 1, 1, 2, 4, 1 from right, 1 from left, but we haven't center number, we have 2 number in the center, then we can average from these two. It is 1.5. In this case, the median, it will be 1.5. Then it's very easy. For example, I write other example. Like example is very, then we can say for the mean, we can use average of the system. For the mode, which more frequently is repeated, can be used mode. And after sort the data, we can find the median, which is the average number in the middle. For example, other example. As you see, we have 11 number. Okay? As you see here, the grade of the test 11 students. We can make a graph also for the students. It is a continuous variable. The average will be the sum of this data divided to the 11 at the end. It will be 47. We can find. Okay? And if you see, in this case, the mode, it is more frequently system. If you see more frequently, it is the 100, is more repeated. 12 is 2 times, then we can say mode is 100. And what is the median? We start right from the small to high. Okay, it is good. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It is a 5 from right, 5 from left. And this number in the middle, it is a median. Now we write in the good situation, good sort, but if not the good sort, we have to do it in the good sort to find of the median. As you see here, relation between the mean, median, and the mode. In the system, in the symmetric curve is very important. Mean equal, median equal mode. It is very important, okay? Because if the system is symmetric from both sides, in this case, all of these three can be the same. But if we have a skewed to right or the left, if the right, in the right, if you see here for the right, in this case, mean is bigger than median and bigger than mode. But if we try to the skewed to left, in this case, mode bigger than median and bigger than mean. As I mentioned, the median is the middle number and the mean is the average of this our data set, and the mode is the most repeated number, which can be found easily. Now we explain about the problems. Then we first start to make a set data table or set of data. And for distribution, the mean is greater than the media. What is the shape of the distribution? It's a very easy question. We can be explained for this problem with this table. Is very, very easy. As you see here, if the symmetric, all of the mean, median, and mode is the same, and the square to right is mean bigger than median, bigger than mode, and if to square to left, in this case, mode bigger than median, bigger than mean. As you see here, the distribution, if you see here what I explain here, we can see the on the set of the number we can find. I write some example here, you can see, and please write also other example for yourself about these data. Now we go to the measure of the dispersion or variability of the data. Okay, it is other set of data is very important, which is related to our work. The first of the information which is very important is range. Range is the difference between the largest number or largest and smallest or minimum. As you see here, it is a range, so it can be range. It's very easy. If we have a data set or data table, we can find very easily. And the other one, we have a IQR or interquartile range. It is different between the third and the first quartile. For example, if we have a 75% and 25, between these two is it can be IQR. It's very important. And we have a percentile which shows between the 5 to 95%. Okay, which can show for us p-value or 5%. 5% percentile as shows the value below, which is 5% in the case fall. These two is very important. Now from these two we can understand very easily about quartile. We have a first quartile, second quartile, third quartile. First quartile is equal 25% of percentile, and second quartile is in the center, or we have say median the 50%, and the third quartile it is shows in the 75 percentile. It is in the last third. And for the variance and the standard deviation, variance is the average of a squared difference in the mean. It is very important. If for the variance, if we find the difference between the mean and our data, in this case, we can, in the power 2, divide to n-1. It is a variance, but in the standard deviation, usually is the radical of variance. Is very important. Measure the dispersion of the data around the mean, and we can find also coefficient of the variation is very important. In this case, if we divide the standard deviation to the mean, is very important. It shows in the system information about the variance. For example, we have one example. It's very easy. We have a set of data, 1 to 4. We can sort of them. It's 1, 1, 4. For the median, 1 right, 1 left, and the median, it is 1 plus 2 divided 2 is 1.5. Range is the maximum, minimum minus minimum is the 4, minus 1 is the 3. And we can have also average or mean. And the mode is 1 because we have a frequency 1 repeating. And mean is 2. And as you see here, if we set a data, if the quotient after this system in our data, we can see the different system here. The first Q1 is the 1 because the first one. Second one we can see between, because we have a 4 number, these two, average of these two is 1.5. And the third one between this one QC is the, between these two is the for 75%, it is 3.5. As you see, or 3 or 2.5 according to different methods. And if you see, we can find the variance with, I found the average mean is equal to, and the number, it is the 4 number. We can find variance, m-1. In this case, we can 4 minus 1, it is the 3. And we can find this data is variance 2. If we can find radical 2, is 1.1, 1.4. And if we divide again standard deviation to mean, we have a coefficient of variation, then 1.414 divide to the number of this here, mean is the 2, and we can find 0.707. As you see here, if we show in the table how we can make it this quartile in the first, second, third quartile is very here. If we have a maximum here in the data set, we have a minimum is 1 and the maximum 4. And if we feed this the system between these two, in the middle we can find 1.5, it is in the middle. And between these two, again, we can find again in the middle, it is a 3 or 2.5, also depend for the type of the calculation. Now we can find other methods. The use of the sample characteristic in summary of table is very important table. For the mean we can, or median, we can use several dispersion. For example, we can use a standard deviation or standard error. Okay, then we can find for every value of mean, we can find a standard deviation. Then we can add plus or minus standard deviation by the mean or standard error by the mean. But with the median, we have a minimum or maximum, usually depend for the situation we want. For example, if we have a graph like this, if you see here is the 5%, here is the 95%, here is the 50%, it is a 25%, here is the 75%. It is depend what state of data we need. If we need between these two, it shows 25 to the 75, or we need a 5 to 95, it must be symmetric, and we can show. And we can have a minimum, maximum, we can find the median or we can have a percentile 5 to 59, 95, and percentile 20 to 75. I show one example for the summary of the measurement of the continuous variable, which shows about the patient, for example, or students. As you see here, we have a number of the individual, for example, patient in the students, and we have a variable about this student or patients, and for every of them we have a median, we have a mean, and we can find the standard error. We can have the plus minus standard error. We can find the range between the minimum and the maximum. We have a median, which is in the, for example, in the middle, in the center, and we have a mean average with the standard error, plus minus. Again, we can have a range for this system. As you see here, in these two tables, we can see very nice information, which is, okay, which is two tables. In the right side, we usually use validation set of the data. It is between the 55 number, and in the left we use a training set, which is the number of the again, it is 83. As you see here, if the number is higher or lower, it depends for the, if we wanted the training or if we would like to about the validation. And about displaying data, we can again come back to with our last study about the type of the variable. We have two type of the variable. It is a categorical and continuous. Usually because categorical variable are definite. In this case, we can use a bar or P chart because we know, for example, about the gender. We know about the gender. We have a 2, or we can use a P chart. But in the continuous, because we have indefinite, we can have a just range between the minimum and maximum. We can have a histogram, or we can have the dot plot, or we can have the mean dispersion diagram, or we can have a box-whisker plot, and we have a scatter plot, and all of this shows it about continuous data, which it is very important for example, we can use example for the age or height or weight or all of this information. For example, we have a dot plot in the left side and histogram the right side. It is about age, both of them, the same shape. It shows frequency, and in the left side we have a histogram, and in the right side we have a dot plot. Or we have a mean dispersion and diagrams. As you see here, we can show the means with the standard deviation. If you see means here, and we can have a positive standard deviation, and negative standard deviation, we can show both of these. Again, we have a categorical variable for the male and the female, and we have also mean and standard deviation in the system. And also we can make a plot, a mean plot, as if you see, we can show in the other form of the mean. And in the x-axis, both are gender, but in the y-axis can be other body mass, mean of the mass, or average can be acceptable. Or we can use mean with mean dispersion diagram, again with the standard deviation, standard error, and we can also use other data. It's very important. After finding the mean, we can after find of the mean, we can add the standard deviation or error or other information which is important. And we can use a box plot. Box plot is also very important. Usually box plot, for drawing a box plot in the middle line, it is a median or IQR. And then we divide 4 parts, and we can have a 25% for Q1, 50% for median, Q3 is 75%, and in the minimum and maximum we can have 100%, which shows the relation between this system. And we can see the minimum here and the maximum is here, and we can see the Q1, it is the first quarter, second quarter or median, and we have third quarter, which is important for us, and we have to find the number and which we can use it very easily. For example, we have a data set here. For example, we have a minimum 150 and maximum 185. And in this data, we can find easily the Q2 because it is the average. As you see here, between these two, or median, and the median is 108, 70. And we can find between 150 and 170 about this table of the graph. Is the P25 is the 165 is here, and for the Q3 100 is here, almost here in this graph, and we can see it is around 173. As you see, if we change to the box plot, we can find here is the median, here is the minimum, here is the maximum, it is a Q1, it is a Q2, it is a Q3, which shows the system for us. As you see here, the answer is here for other graph. Again, quarters and the box plot, we can see both of them in the same system. It is a left skewed, and if you see the median is around 59, okay, and we can find the Q1 is around 52.5, and Q3 or P75 work, we can find about 67. And from this paper, we can find here is the minimum. Again, we have a maximum, we have a median, or we can say other name is Q2 or P50. This is the Q1 or P25. Here we can show Q3 or P75. We can show the all of the graph. It is in the histogram and the box plot. Or we can show in the scatter plot. A scatter plot is shows by the spots. For example, in the VC, it is the hours, study hours. And we have a grade, for example, mark the student got. It is a y-axis, and also we have a study hours in the x-axis. As you see here, we can make a spot between every information. For example, Jane is between 8 and 70. As you see here, we can also make this type. We will study also, it is the x-axis and the y-axis, and we study about, we can find also mean or other information in the line and make a graph in this part of the graph. Also, we can have a two type. As you see here, it is more acceptable because data, it will be like a set of data in the variable is related between the body mass and if you see here, and pretty much 3 years ago. But here we have a not symmetric, not good information. Our data can be not good because in the data is not has a good relation, and we study again R square is not good. Here is the good big value. Here is the very can be very small value and not acceptable. And we use transformation of the data value and addition and subtraction. We can use this also. We can add or we have subtract the same number of each value in the every data sheet, in every variable sheet. We can use for all of this system we can use, and it is also acceptable. When we use the same adding of the set of number in the same table, it can be acceptable. And also we can do divide or multiply our data set in one number is acceptable, is the same. For example, here it is important. If you see here, for the addition, we have a sample, we have a mean is 2. I add, for addition, if you see, I add a 10 for each individual. We see the mean also at 10. Okay. Also median also add a 10. Range is the constant, and standard deviation constant. Also we have elimination minus 10. Again, same situation until the end. And again, range is the same, and standard deviations. If we have a multiply, for example, 10 times from the first, it is from the plus here, minus here, multiply here, again multiply 10, and range and standard deviation will be the same. And if we divide by 10, again we will see the mean and the standard deviation is the same and not affect. Then we can say if we have a set of data, we can add some fixed number and or divide or multiply, and we can use this data date. The last part I would like to speak about is spatial transformation or standardization. For this situation, we usually use z-square. I want to just explain a little. In the next lecture, we will continue with this value, and I hope it can be good. It was our first lecture about statistics, and we can see it in the next lecture about